Today we're going to be taking a look at polynomial long division and how we can use polynomial long division to take care of something like this, to divide a polynomial by another polynomial. Now before I do this example, I'm going to go with a simpler one just to show you how this is similar to and basically the same thing as long division like you learned it back in grade school. So here we have an example of 277 divided by 12. And of course this starts off by asking the question, how many times does 12 go into 27? And of course that's going to be twice. And then we'd put our 2 up here, multiply 2 times 12 is 24, and subtract. And when we subtract, we'd get 3, and we'd bring down the 7. So I'm going to stop there and go over to my polynomial now. In this case, I've picked the polynomial so that it has the exact same coefficients as the number I'm dividing over on the left-hand side. So we're going to ask ourselves the same question. We have x plus 2. How many times does that go into 2x squared? In other words, what do I have to multiply x by to make it 2x squared? And so in this case, it's 2x. I'm going to do the same thing, multiplying my x plus 2 times 2x, and I'm going to line up the positions, the x squareds and the x's here. So 2x times x is 2x squared, and 2x times 2 is 4x, positive 4x. And just like on the other side with the numbers, I'm going to subtract. The 2x squared minus 2x squared is going to cancel out and be 0. 7x minus the 4x is going to give me 3x, and I'm going to bring down my 7. And so you'll see in both equations here, both examples, the number and the polynomial, we end up with the exact same numbers. Now that's not always going to happen because of the things like carrying we can do in the real number system that we can't do in polynomials. So back over to our number, we're going to ask the question again, how many times does 12 go into 37? And this time it's going to go in 3, and that's going to be 36. We'll do subtract, and we'll get a remainder of 1. So we'd say it's 23 with a remainder of 1. And of course, if we remember what that means, it really means we have 23 and 1/12 left over as a mixed number. We could do that as a decimal, but we're going to leave it as a mixed number. On the polynomial side, we're going to do the same thing. How many times does x go into 3x? Or in other words, what do I have to multiply x by to make it 3x? And so in this case, it's going to be a positive 3. We'll multiply 3 times x plus 2, and that's going to be 3x plus 6. And again, we'll subtract. And you'll notice we're getting the exact same numbers. Polynomial long division is the exact same thing as long division with numbers. And so when we subtract 3x minus 3x is 0, 7 minus 6 is 1. And so just like in the other one, we have a remainder of 1. Again, we're not going to be writing it that way for the most part. We're going to be writing it in this mixed number form. And so we'd write 2x plus 3 plus 1 over x plus 2. And so I'm going to refer to that as mixed number form in class. And we'll be writing most of our answers in that form. Now, let's go ahead and look at a little bit harder example here. Back to this first one. For this one, you'll notice we have an x to the fourth, an x to the third, and x squared, but we're missing those last two terms. It sometimes is helpful if we fill them in. And so I'm going to go ahead and fill those in when I do this. So we've got 2x to the fourth minus x to the third plus 9x squared plus 0x plus 0. I don't for sure need those, but I'm going to leave them in there for now. And my divisor is x squared plus 4. So same thing as last time. I'm looking at this first term and I'm going to ask myself, what do I need to multiply by to make x squared 2x to the fourth? And so I'm going to have to multiply by 2 to get the coefficient, and x squared to get it to be x to the fourth. So I'll multiply. That gives me 2x to the fourth here. And 2x squared times 4 is going to be 8x to the fourth. I'm going to go ahead and put that over here. Sorry, 8x squared. I don't have any x to the third terms, and you could put a 0x squared in there if you wanted to, but we don't really need to. Just make sure you're lining up your terms just like you do any other time. So we're going to subtract. 2x to the fourth minus 2x to the fourth is, of course, 0. Negative 3x to the third minus 0 is negative x to the third. And 9x squared minus 8x squared is 1x squared. And then I'm going to go ahead and add the rest of these terms in. Just drop them down. Again, I'm going to go back and I'm going to ask myself, what do I have to multiply x squared by to make negative x to the third? And that's going to be a negative x. And so I'll multiply by negative x. And I'll get negative x to the third. I don't have any x squareds, but I'm going to have negative 4x. Now here I'm going to have to be careful when I subtract. I'll do this in gold just to show this a little bit differently. When I subtract here, I need to subtract both terms. So that's really subtracting a negative. We're going to be adding in the end. So my next step here, I'm going to add or subtract my negatives, which is really adding. Those are going to cancel out. 1x squared, just dropping that down. I don't really need the 1, but I guess it's there. Plus 4x and plus 0. And the last step here, how many times does x squared go into x squared? Well, that's just going to be 1. Which gives me x squared plus 4. And subtracting, those are going to cancel out. I'm going to get 4x minus 4 as my remainder. You can't see any of that. So 4x minus 4 is my remainder. Again, making sure we're subtracting. And finally, I'm going to need to write that as a mixed number. So I'm going to end up with 2x squared minus x plus 1 plus 4x minus 4 over x squared plus 4. And so I have my quotient plus my remainder over my divisor.